Today we are going to review confidence intervals and find the sample size using the margin of error. If you need a refresher over confidence intervals, there is a nice informative video here at this link, so feel free to go there and watch it as well. Oh my goodness. When we are choosing our sample size, you have to ask yourself how large a sample to take is an important step in planning any study. You want to choose in a margin of error and a confidence level. Remember, the formula requires p hat, which we don't have yet because we have not taken the sample. A good estimate for p hat, which will yield the largest value for p hat times 1 minus p hat, and therefore n, is 0.5. And then we just solve the formula for n. So what that statement means is if you have a situation and you're not given the proportion, you can use 0.5 as your p hat, because it's the largest value that we can use for a good estimate. Whoop. Oh my gosh, why does it keep doing that? So now we're ready to do some examples. The Fox News poll was estimated that 82% of all voters believe global warming exists had a margin of error of plus or minus 3%. That's probably important, so I'm going to highlight that, and we also have the estimated 82%. Suppose an environmental group planning a follow-up survey of voters' opinions on global warming wants to determine a 95% confidence interval with the margin of error of no more than plus or minus 2. How large a sample do they need? We're going to use the Fox News estimate as the basis of our calculation. So when we do this problem, the first thing we are going to do is we are going to use the margin of error they want us to use, 0.02 equals. Now, for a 95% confidence interval, remember the Z star. If you're thinking in your mind a 95% confidence interval, then that means you want the middle 95%. Okay, that means there's 2.5% over here, and therefore you would have to use inverse norm 0.975. Okay, so you have to use inverse norm 0.975, and it should give you 1.96. So from there, we have our square root, and we're going to use the proportion that they provided us already in the example. So our probability of success is 0.8. Our probability of success is 0.82. And that means our probability of failure is 18%. And because we don't know the sample size, we're going to use n. Now, to solve, you could divide by 1.96 first if you wanted to. And remember, to get rid of that square root sign, you're going to square both sides. Okay, now you have a fraction equal to some number, so you can multiply both sides by n. And then you divide both sides by 0.02 divided by 1.96 squared. Now, if you are just doing this all as one huge step in your calculator, you need to be very careful. What I would suggest you do is you take 0.82 times 0.18 and hit enter in your calculator, then hit divide by and put the fraction 0.02 divided by 1.96 squared in parentheses. If you do not put it in parentheses, your calculator will do order of operations and it will divide it by 0.02 and then divide it by 1.96 and then square that result, and it will give you the wrong answer. Now, could you have used a decimal approximation initially with 0.02 divided by 1.96? Yes. Could you have used a decimal approximation for 0.82 times 0.18? Yes. And you do get something about 1,417.55. Now, for these problems, we always round up because we are referring to a sample. So we're going to say this is approximately 1418, and then we write a statement in context. Okay. So let me get my box here. So we are going to say the environmental group will need a sample of about 1,418 respondents. And that's all we wrote for our example. In our last example today, suppose that you want to estimate P equals the true proportion of all students at your school who have a tattoo with 90% confidence and a margin error of no more than 0.07. So just like before, we are going to highlight key information. We want to estimate the true proportion of all students at our school who have a tattoo with 90% confidence and a margin of error of no more than 0.07. And for us to determine our number of students should be surveyed, we're going to do something very similar in the previous example. First thing we're going to do is we're going to set up our margin of error, which is, and that's going to equal, now for a 90% confidence interval, remember you're thinking in your mind, if you were to draw a bell curve, you want the middle 90%. That means there's 5% on the lower end. So to find your critical value or your Z star, you're going to do an inverse norm of 0.95. Okay, so you're going to do an inverse norm of 0.95. This should give you about 1.645. Now this time, notice that they did not give us a p hat or a proportion. If they do not do that, we just use 0.5. So our probability of success is 0.5, and our probability of failure is 0.5. And now we're just going to solve this very similarly to how we did the previous problem. So first thing we're going to do is we're going to divide by 1.645. Next thing we're going to do is we're going to get rid of that square root sign by squaring both sides. From there, you're going to multiply both sides by n. And then you're going to divide by 0.07 divided by 1.645 quantity squared. Remember, you're going to type 0.5 times 0.5 in your calculator first and hit enter. Then you're going to hit divide by a parenthesis, 0.07 divided by 1.645 close the parentheses, and then square it. Remember, if you do not put parentheses around that fraction, your calculator will give you the wrong answer because it only understands order of operations, not how you intend for it to calculate. When you do so, you do get n to be approximately 138.06 or about 139 students. And then all that's left for us to do is to write a statement in context. Okay, so here's our statement. We will need a sample of about 139 students to have a margin of error of no more than 7% to determine the proportion of students with a tattoo. And that's all we have for that example. And guess what? We're ready for practice time. Hooray, the end.